Let's continue the learning on the limits. Here are limit properties. We have sum rule or addition rule, subtraction rule or called difference rules, constant product, quotient, power, root rules. If the function is a polynomial, that means the domain x could be any real numbers. Then just simply replace x by c to get the limit, because the function is continuous at any point. Suppose the function is a rational function, variable in the denominator. We know the denominator can't be 0, therefore we have to be careful. Only the c in the domain, we can plug c in the function. Now let's figure out all the following limits. Determinant, that means the answer is a number, is a finite number, a fixed number. Indeterminate, that means the limit does not exist. For this one, the given function is polynomial. X is not in the denominator, not in the even root. X could be any numbers. So we just replace the x by 3. So the limit is 7. That means x can approach 3, also arrive at 3. 2x plus 1 is continuous at x equals 3. This rational function, we see x minus 1 can't be 0, x can't equal 1. Luckily, 2 is in the domain. Simply replace x by 2. So the answer is 5. Similarly, this one, x can't be 2, but the 4 is in the domain. Plug in 4 for x. Next, let's working on these 3 limits. Every one is in 0 over 0 form at each given x value. So it's in 0 over 0 form. The strategy is to fact the rational function and reduce the fraction, then find the limit of the result. Like for this one, when x is 2, numerator and denominator both are 0. Apply the formula a squared minus b squared is a plus b, a minus b. So by the factoring, the numerator is x minus 2x plus 2. X minus 2 is a common factor. So now we completely remove the whole denominator. Plug 2 in the function is 2 plus 2 is 4. The next one, by FOIL factoring, the numerator has 2 factors. And the denominator also has 2 factors. The common one is x minus 1. So these factors that causing the denominator in 0 is cancelled out. So we simplify the fraction. Since 1 is in the domain, we plug 1 in this fraction, then our answer is negative 1/2. Let's repeat the strategy for this limit. Apply FOIL factoring x plus 4x minus 1. Because it's 1, 1, right? 4, negative 1. And x minus 3. But this time, we are out of luck. No common factors between numerator and denominator. So we can't remove the denominator. So this actually is turned to be a finite number over 0. The limit is positive infinity as x is approaching 3 by the right side. X is approaching 3 from the left side will go to negative infinity. So then this limit DNE does not exist. We are going to do the summary in the next video. Next, for the piecewise defined functions, these two examples are pretty clear because the given functions are polynomials. So the domain x can be any real numbers. X is approaching 5 from the left side because less than 5. So it is 7x minus 10 is 25. The right side is the limit. X is approaching 5 from the right side. We choose this function. So then is 25 too. Since the right side and the left side limits are the same, the limit is 25. The next one, x is approaching 1 from the left side. We have to choose this, the top function. So is x squared plus 1. So we get a 2. Right-sided limit is choose x plus 1 is 1 plus 2 is 3. Since the left and the right side, they are not approaching the same spot, so then this limit DNE does not exist. Once again, we will do the summary in the next video.